searching houses for him to retire in. You can get a nice...
Okay, Jacob, sorry this took so long to get started. It is now 10 minutes of 9. I tried to restart the computer multiple times and it finally did start. We've gone over the whole assignment and we've done volumes by shells. Look that up on YouTube, it'll be great. Try to find the girl that says, "Hi everyone." Yeah, you can look for her. She'll be good. And also, Soph took some still pictures for you also. All right, so we are now going to do volumes using known cross sections.
Like a sniper?
Yes.
Sort of like a sniper. Sure. And we need to remember this very simple concept. Volume is equal to the integral of the area. That's the big concept here. So let's say that we wanted to find the volume of the region bounded by y equals 2x, the x-axis, and x equals 3, with squares extended out of the region. So I'll explain what all that means. You get all that scribbled down and I'll explain. Okay, so we're going to have our little region right here. So we got y equals 2x, and we're going to go all the way to 3. So here is our region. So there it is. We have our region right here. Oh, damn it, I did not make this big enough. Oh yeah, I did. Perfect. Okay, good. That'll work. Sorry.
What is that equation?
Y equals 2x, yep.
So it's straight.
Okay. So what we're doing here is we're having squares extending out of this region. So I have prepared a nice little square for us. And this square would be right about here. So this would be one of how many squares growing out of this region?
Infinite.
An infinite number of squares. And so going back to this concept over here, volume equals the integral of the area. All I need to do is represent the area of the square and integrate.
I don't get it.
Okay?
Can you repeat the square thing?
Yep. So the idea of the square is in what's happening here?
Yeah.
Okay. So, and I'll actually extend it a little bit. So here we have a square. So we have a triangular surface, like imagine a triangle on the floor.
Okay.
And what we're going to do is we're going to take like pieces of plywood, 1/4 inch plywood. We're going to cut a 1/4 inch plywood, and the base of the plywood square is going to be from here to here in the triangle. That's going to be our first piece of plywood. Put that down, standing up from the floor up.
Okay.
And then when we go and measure the next one, it's going to be a little tiny bit smaller, right? Because we're on an angle here.
So, if I'm picturing this correctly, the squares, are they going to, so like, if it's on the ground,
Yep.
and you have like squares, is it going to get,
That's correct.
okay,
We're going to have big squares here, and gradually smaller and smaller squares till we get over to here. Very tiny squares down near the point. Does that make sense? So it's wedge-shaped, because it's tall here and narrow here, and it also gets pointy this way. Does that make sense? So, again, back to the concept, volume equals the integral of area. Here is an area, and it's in the shape of a square. How do we represent the area of a square?
Square.
So x squared is just x, but,
X.
so, how do you find the,
Length times-
ignore this.
or
Here it is, it's just a square out in space. How do we find the area of a square?
Height times length.
Side squared. If we know the length of the side, we square it.
Mm-hmm.
Okay, watch up here. What's the length of my side?
2x.
Right, it's just the height of the thing, right? It's 2x. Does that make sense?
Mm-hmm.
Does everyone see that fairly clearly or not so fairly clearly? Not yet? Okay. So we have an infinite number of squares, and all of them have a side length of 2x. Right?
So is it 2x over?
Because the
x
square
squared?
goes from here, right down to here.
And that's kind of
That's
like
my
our
square.
radius.
Kind of like the radius. It is
Like,
an
making
important
connections
measurement
to what we
in,
want.
yes, it's an important measurement for us to find the area of something. So the radius was important for us to find the area. The side length is the thing we need to find the area of the square. Is that okay?
Yeah.
All right, great. So let's go back now and set up our situation right here. So we're growing squares out of here. So we need to set up our integral. But before we set up the integral, what's the area of a square?
Square.
Is side squared. So if we just know the length of a side, we just need to square it and then we integrate. Everyone's good?
Mm-hmm.
Great. So the length of the side of our square in this particular problem is going to be
2x.
2x. So then our volume is going to be the integral from 0 to
3.
3. The side length is
2x
2x
squared.
squared, because now that represents the area. dx.
That's it?
That's it.
Doesn't seem too difficult, but I'm sure
It's
it'll
not-
probably get harder.
It does get more challenging, but it's conceptually a little harder to visualize, I think.
Yeah.
Right, we can all see something rotating around, but how do we visualize this thing right here?
I
That's
like the
why,
idea of the stacks of plywood.
yeah, that was helpful? Good. So that's why I do a little visual with the paper, but the plywood apparently was a little bit better. Are we good here? Okay, so I just wanted to introduce that concept. We're gonna do more on it, because in addition to squares growing out of a
There'll be
region,
rectangles.
we can have rectangles growing out of the region,
Triangles.
triangles growing out.
Oh!
I've never seen trapezoids, but I have seen semicircles.
Rhombuses.
No rhombi.
Rhombi.
What on
Squares.
earth?
So, and all we need to do again is just set up the area. What's the area of a square? It's pi r squared. Right? That's it. Just set up the area and you're good. Sometimes it's just a little difficult to figure out what the area is. Everyone got the intro to the concept?
Yeah.
Good. All right, awesome. We're going to have calculus tomorrow. We can continue. So let me stop this here.
Homework.
Homework.